Hello and welcome to another math video. Today we're taking a look at our Chapter 11 quiz for sections 3 and 4, talking some probability questions. For number 1, we just have two independent events, Q and R. We want to find the probability of Q and R. All we do in order to do that is we just multiply those probabilities together. So we'd have the 0.41 multiplied by the 0.44. Let's see. And that turns out to be exactly 0.1804. You can write that either as a percentage or a decimal, but again, that's exact, so don't, if at all reasonable, don't round if unless it's totally necessary. Number 2, we've got an urn, which got white balls and yellow balls in it, or two urns, I should say. First one has 9 white and 9 yellow. So 9 white, 9 yellow in the first one. Second one has 8 white and 3 yellow. You draw one from each urn. What is the probability that both are white? So again, these are independent events because it's separate urns. The first one has a 9 out of 18 chance. So we'd multiply that by the second one, which has an 8 out of 11 chance. And we'd multiply that together. See what we come up with. Let's see, so 9 times 8, we'd be looking at 72. Then 18 times 11, we got 198. That does reduce, of course. Reduces down to 4 out of 11. And again, probably best just to leave it as 4 out of 11 rather than rounding it as a decimal. Next one, we know that S and T are mutually exclusive events. Find the probability of S or T. So all we do then is add those together. This one's written as a percentage, so we could just do 20% plus 22%, and we get 42%. It's as simple as that. Number 4, jar contains 7 blue cubes, 4 blue spheres, 5 green cubes, and 6 green spheres. If you select an object at random, what is the probability that the object is green or a cube? So let's see, green or a cube. Oh boy, okay, so we got 7 blue cubes, 4 blue spheres, 5 green cubes, 6 green spheres. So we're talking 22 items altogether. If you look at the ones that are green, we've got 11 green out of 22, so that's half, but I might leave it as 11 out of 22. We add to that the number that are cubes. We got 7 and 5, so that's 12 out of 22. But then we double counted the green cubes, so we subtract 5 out of 22 for that. And so we end up with 18 out of 22, which turns out to be 9 out of 11. And again, I would just leave that as a fraction. The decimal's not nice to deal with here. Number 5, we got Joey's sock drawer is unorganized, contains 3 black dress socks, 5 black ankle socks, 7 brown dress socks, and 6 brown ankle socks. What is the probability that Joey will blindly reach into a sock drawer and pull out a sock that is brown or a dress sock? So kind of the same question. We're looking for either brown or a dress sock. Let's see, we got 3, 5, 7, and 6, so that's 21 total socks in there. Let's see, so brown socks, we got 7 and 6, so that's 13 out of 21. Plus dress socks, that's 3 and 7, so that's 10 out of 21. But then we double counted the brown dress socks, so we would subtract 7 out of 21. And there's other ways you can do that, but this one turns out to be 16 out of 21. And again, I would just leave it like that. No need to mess with that at all. Let's see, here we've got a table that shows the results of a survey of students in 2 math classes. Find the probability that you got more than 1 hour of TV given that you're in the 6th period class, round to the nearest 1,000th. So here it is telling us to round, so obviously we'll do that. For me with these, I would always find it easier just to kind of focus on the information that we need to focus on here, in this case, the 6th period class. You know, if I could put a circle or somewhere on that. So that's 23 people, And we're trying to find probably that they had watched more than 1 hour of TV. So it'd be 13 out of 23. So again, that's just the simplest way with these. If they're going to give us all of that information, may as well do that. To the nearest thousandth, which is 3 decimal places, 0.565 is what we're looking at for that one. Number 7, each person in a group of students was identified by year and asked when he or she preferred taking classes, morning, afternoon, or evening. The results are shown in the table. Find the probability that the student preferred afternoon classes, given he or she is a junior, rounding to the nearest thousandth. And apparently this didn't copy very well because the information is on the next page. So afternoon classes, given that they're junior, and here's our information. So we're trying to see the probability that they prefer afternoon, given that they are a junior. There we go. And again, you could use our formula here, but given that we have the table, we may as well do that. So looking at just the junior part, 13 prefer afternoon classes out of a total of 28. They did say to round to the nearest thousandth, so we get 0.464 for that one. Number 8, we got the probability that the city bus is ready for service when needed is 84%. The probability that the city bus is ready for service and has a working radio is 67%. Find the probability that a bus chosen at random has a working radio given that it is ready for service. And so here we are going to have to use our formula because we don't have a full table. So again, we kind of have to untangle the information at least a little bit in order to figure out what we're doing with this. So we've got the probability that the bus is ready for service when needed is 84%. And so just a reminder too what that formula looks like. Probability of B given A equals probability of A and B over the probability of A. And so what they have for us is the probability, finding the probability that the bus chosen at random has a working radio given that it is ready for service. So radio that works given that it is ready. And so that gives us an idea of how to set this up. So the two of them together goes over the probability that it is ready. So let's see, the probability that the city bus is ready for service is 84%, so that would go on the bottom. And the probability that it has ready for service and has a working radio is 67%, so that would go on top. So 0.67 over 0.84, and what did they say, around to the nearest tenth of a percent for that one. So that turns out to be 79.8% for that one, 79.8%. Number 9 is similar. The probability that a student at a certain high school likes art is 63%. Probability that a student who likes art also likes science is 34%. Find the probability that a student chosen at random likes science given that he or she likes art. So, let's see what we're looking at for this one. Probability that they like science given that they like art. That's what we're looking for. So we'd have the probability that they like both on the top. I'm just going to put both. And then we would need the probability that they like art on the bottom. And of course, those are the numbers that we have. The probability that they like both is 34%, or 0.34. Probability that they like art is 63%, or 0.63. Around the nearest tenth of a percent again. Let's see. So that turns out to be about 54.0%. And again, the 0 is important. That shows that I did actually round to the nearest tenth for that one. And number 10, we've got our question. This is going to be where we need to make a tree diagram. We've got participants in the study of a new medication received either medication A or a placebo. Make a tree diagram of the results, then find the probability that the patient got the placebo and they felt like there was improvement. So of all those who participated, 80% received medication A. Whoops. Get my marker going here. So the ones that got A, that was 80%. That means 20% got the placebo. Of those that received the medication, 76% reported improvement. So 76% felt like it improved, and that would mean then that 24% did not improve. I'm just going to put not. And then of those that got the placebo, 62% reported no improvement. So I'm going to keep that on the inside, I think is how I would do that. You could set that up differently if you want. But if 62% said no improvement, that would actually mean that 38% said that they felt like they improved just from getting the placebo. And they want us to find the probability of placebo and improvement. And again, going back to our formula, probability of B given A equals probability of A and B over the probability of A. So what we have is we want to find the probability of A and B. So we would actually multiply the probability of A by the probability, by the probability of B given A. Again, really just doing that to both sides of the equation to get the probability of A and B, which I'm going to run out of room there because I could slide this way a bit. Okay, that'll tell us. Because the 38% here is the probability that they felt improvement given that they had the placebo. So, and the probability that they got the placebo is 20%. So really we just do the 20% times the 38% in order to get our answer. So 0.2 times 0.38. So about 7, or exactly 7.6% felt that got the placebo and felt like they had improvement. Well, I know this was kind of a quick one, but hopefully you found the video helpful, and as always, thank you for watching.